So today we are going to discuss about semiconductor electronics. It is the chapter 14 of NCERT textbook 2. Have you seen it? Semiconductor electronics, materials, devices and simple circuits. Now what is electronics? Electronics is the applied science, applied physics. Okay? And what is semiconductor? I think you already heard the name called a semiconductor. The conductivity of semiconductor lies in between conductors and insulators. The conductivity is very, very large in metals. It is perfectly zero for the insulators, and in between them, in between the metal and insulator, there is a material called a semiconductor. We already discussed one or two important properties of semiconductor during the study of current electricity. So what are the basic properties? What is the basic properties of semiconductor? What is the basic property of semiconductor? What is the characteristics of semiconductor? The semiconductor have negative temperature coefficient of resistivity. This is the graph between resistivity and temperature for semiconductor. That means when temperature increases, conductivity of semiconductor increases. That means resistivity decreases. But in conductor, with rise in temperature, conductivity decreases, so resistivity increases. Have you seen this relation? Rho t is rho 0 1 plus alpha t minus t0. This alpha is called temperature coefficient of resistivity. Semiconductor has negative temperature coefficient of resistivity. Conductors generally has positive value. And second property of semiconductor is conductivity of semiconductor can be increased by adding a small amount of impurity to it. I mean, if we add impure atom to a semiconductor, its conductivity can be increased. Okay, these are the two basic characteristics of semiconductor. And before discussing some electronic circuits and about the semiconductor, we initially try to discuss about the energy band of solid. We know that in atom, electrons are in some well-defined energy state called the energy level. But in solid, electrons are in a region called the energy band. Since in a solid, large number of atoms are very close to each other. Therefore, every electron of solid has slightly different energy values. In your NCERT textbook, page number 469, it is written that inside the crystal, each electron has a unique position and no two electrons see exactly the same pattern of surrounding charges. Because of this, each electron will have a different energy level. these different energy levels with continuous energy variation form what are called energy band. The energy band which includes the energy levels of valence electrons is called valence band. The energy band which include energy levels of valence electrons is called valence band, and the energy band above the valence band, is called conduction band. That means we can say that solid has two different type of energy band. Solid has two different types of energy band. Solidot তোমার কি থাকে দুই ধৰণৰ এনার্জি ব্যান্ড থাকে এটা ব্যান্ডক কি বুলি কয় ভ্যালেন্স ব্যান্ড বুলি কয় ভ্যালেন্স ব্যান্ড normally valence band is completely filled with electrons valence band is completely filled with electrons when electrons is in valence band it is not free to move from one end to the other end of the conductor. They are bound to their respective atom. Solid has a different type of energy level called the conduction band. অলপ আগতে মই পঢ়ি দিওঁতে তোমালোকে শুনিছা যে তোমাক কি কৈছে the energy band which is above the valence band is called conduction band. Whenever an electron is in conduction band, যেতিয়া এটা electron conduction bandত থাকিব, it is free to move from one end to the other end of the conductor. Electron to এটা endৰ পৰা আনটো endলৈ move কৰিব পাৰিব solid. That means whenever electrons are in conduction band, they are free and they can conduct current easily. So solid has two type of energy band. One is called valence band, one is called conduction band. And there is some energy gap in between conduction band and valence band. Conduction band and valence band. If you see for the metals, either this gap is very small or conduction band and valence band overlap each other. So this is the valence band and this is the conduction band. They overlap each other. Energy gap between them is practically zero. Energy gap between them is practically zero. So since valence band and conduction band overlap each other, if large number of electrons are in conduction band and current can easily pass through them because they have large number of free electrons. So in another type of conductors, the energy gap between conduction band and valence band is very, very small. So since this gap is very small, the electron can easily jump from valence band to conduction band by receiving thermal energy. As a result, a large number of electrons are in conduction band and they can easily move from one end to the other end of the conductor. Okay? So what is the characteristics of conductor in terms of energy band? In case of conductors or metals, either valence band or conduction band overlap each other or there is a very little energy gap between conduction band and valence band. As a result, at room temperature, a large number of electrons are in the conduction band. Since this gap is very large, by absorbing thermal energy, electron can jump from valence band to conduction band. When the electrons in conduction band, they can easily conduct current, so current is easily possible there. There is another category called the insulator. In insulator, what happens? This gap is practically very large. Conduction band is completely empty, valence band is completely filled up, and this gap has very large value. According to your NCERT book, this gap is more than 3 electron volt. If the energy gap between conduction band and valence band is more than 3 electron volt, electron cannot jump from valence band to conduction band by absorbing thermal energy. So therefore, conduction band is completely empty. Have you seen? Conduction band is completely empty. Therefore, current cannot flow through insulator. So there is another material called a semiconductor. Their conductivity lies in between insulator and that of conductor. It is because this gap is of the order of 1 electron volt for semiconductor. This gap is of the order of 1 electron volt for semiconductor. The semiconductor কি হয় এই গ্যাপটো বহুত কম হয়, বহুত কম, 1 electron voltতকৈ কম. So there are certain semiconductor materials. Germanium has the energy gap 0.72 electron volt. Germanium has energy gap 0.72 electron volt. 0.72 electron volt. And there is another material called silicon. Silicon has energy gap 1.1 electron volt. That means at very low temperature, at absolute zero, at 0 Kelvin, conduction band is completely empty, valence band is completely filled up for semiconductor. Since this gap is very large, either 1 electron volt or less than that, at room temperature, some of the electrons absorb thermal energy and make the jump from valence band to conduction band. Since number of electrons in conduction band increases with increasing temperature, therefore conductivity increases. As the conductivity of semiconductor increases with rising temperature, their resistivity decreases. That is why alpha is negative for semiconductor. What is alpha? Temperature coefficient of resistivity. মই অলপ আগতে তোমালোকক কৈছিলো যে আলফাটো তোমাৰ কি হয়, আলফাটো নেগেটিভ হয় সেমিকন্ডাক্টৰ. যে এনসিআরটি আমাৰ যেটা এক্সাম হ'ব, এক্সামত কেতিয়াবা কি কৰিব দিয়ে, এই এনাৰ্জি বেণ্ডটো ড্ৰ কৰিব দিয়ে. যে দিস টু আর ফৰ দ্য কণ্ডাক্টৰ্ছ, this is for insulator and this is for semiconductor. It is given on the page number 471 of your NCERT textbook. Okay? Now, we are going to discuss about the semiconductor element. If you go to the periodic table, the group for element means element which have 4 electrons, 4 valence electrons in their outermost shell are called the semiconductor element. As for example, carbon, silicon and germanium, all these atoms have 4 electrons in their outermost shell. Can you remember the electronic configuration of carbon? It is 1s2, 2s2, 2p2. Yes or no? Carbon atomic number is 6. What is silicon? Atomic number of silicon is 14. So therefore it is 1s2, 2s2, 2p6, 3s2, 3p2. What is for germanium? Atomic number of germanium is 32. So it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p2. Carbon 2 মই তোমাক আৰু এবাৰ লিখি দিছো, 1s2, 2s2, 2p2. So this is the outermost cell, this is the outermost cell, this is the outermost cell, this is the outermost cell. That means in fourth group of the periodic table, they have the 4 valence electrons in the outermost shell, and they are called the semiconductor elements. But though the carbon lie in the same group along with the silicon and germanium, it is not considered as a semiconductor atoms. It is because the size of the carbon atom is very small. As a result, its valence electrons are more tightly bound to the carbon nucleus. As a result, they cannot easily come out of their outermost shell, and hence they behave like insulator under normal conditions. If you go for the page number 474 of your NCERT textbook, so there is a question is there. This question may come this time. Carbon, silicon, germanium have same lattice structure, but carbon is insulator, silicon and germanium are semiconductor. Explain. The 4 bonding electrons of carbon, silicon, germanium lie respectively in the 2nd, 3rd and 4th orbit. Have you seen? The 4 valence electrons of carbon lie in the 2nd orbit, silicon lies in the 3rd orbit, and germanium in the 4th orbit. Since these electrons are closer to the nucleus, so these electrons are more tightly bound. Hence, energy required to take an electron from this atom, that is the ionization energy, will be minimum for germanium, followed by silicon, and highest for carbon. Hence, number of free electrons for conduction in germanium and silicon are significant, but negligibly smaller for carbon. তারমানে কার্বনত কি হয়, কার্বনৰ সাইজটো সৰু আৰু লগতে ভ্যালেন্স ইলেক্ট্ৰনবিলাক সেকেন্ড অৰবিটত থাকে। সেইকাৰণে তোমাৰ কি হয়, ইলেক্ট্ৰনবিলাক মোৰ টাইটলি নিউক্লিয়াছৰ লগত বাউণ্ড হৈ থাকে। এজ এ ৰিজাল্ট, by absorbing the thermal energy, electrons cannot jump from valence band to conduction band easily, and therefore carbon is insulator. But germanium and silicon, they have their valence electrons are in the 3rd and 4th orbit, though they are far away. They are away from the nucleus, therefore they are loosely bound. Therefore they can easily jump from the valence band to conduction band. মই অলপ আগতে তোমালোকক কৈছিলো জাৰ্মেনিয়ামৰ কাৰণে এনাৰ্জি গেপটো কিমান হয়, 0.72 ইলেক্ট্ৰন ভোল্ট, আৰু সিলিকনৰ কাৰণে কিমান হয়, 1.1 ইলেক্ট্ৰন ভোল্ট. Why? Because in silicon the valence electrons are in 3rd orbit, therefore energy gap is slightly more. In germanium the valence electrons are in 4th orbit, therefore energy difference is slightly less, 0.72. Is it clear? The semiconductor in pure form is called the intrinsic semiconductor. The semiconductor in pure form is called the intrinsic semiconductor. Okay, we must know how to increase the conductivity of semiconductor. So in order to increase the conductivity of semiconductor, initially we must go for their electronic structure. So since the silicon has 4 electrons in its outermost shell, so therefore it will make covalent bond by sharing 1 electron each with 4 neighboring silicon atoms. By sharing 1 electron each with 4 neighboring silicon atoms. So as a result, its octet is completed. At 0 Kelvin, all these covalent bonds are completely filled up. Therefore, not a single electrons are free. Therefore, conduction band is empty and valence band is completely filled up. But at room temperature, some of the electrons absorb sufficient thermal energy and they come out of the covalent bond and they becomes the free. As soon as this electron becomes free, this silicon loses its octet. So as a result, a deficiency is created near this silicon atom. And this deficiency of electron is considered as a charged particle and it's called a hole. A particle to a charged particle buli consider kore arthat hole buli koy. Electron mane electron. Hole mane tumar ki hole to get a positive entity buli consider kore. Its charge is minus E. Its charge is plus E. Mass is exactly same as that of the electron. That means when the electron make jump from valence band to conduction band, number of electrons in conduction band increases. That means more electrons are free in conduction band. As a result, some deficiency appears in the valence band, and this deficiency of electrons in the valence band are called the holes. So in a pure semiconductor or in intrinsic semiconductor, number of free electrons is equal to number of holes. And this gap is of the order of 0.72 electron volt for germanium and 1.1 electron volt for silicon. All of notes to পঢ়ি দিছো শুনিবা. The pure semiconductor in which electrical conductivity is totally produced by the electrons excited from valence band to conduction band, and in which no impure atom are added to increase their conductivity are called intrinsic semiconductor. Here, number of free electrons in conduction band are equal to the number of holes in valence band. In silicon and germanium, their 4 valence electrons make 4 covalent bond with 4 neighboring silicon atoms by sharing 1 electron each. At very low temperature, all these covalent bonds are filled up and hence no electrons are free to conduct electricity. Thus, conduction band is completely empty and valence band is completely filled up, and hence in semiconductor behave as a perfect insulator at 0 Kelvin. But at room temperature, some of the electrons have got sufficient thermal energy to come out from their covalent bond and becomes free. Thus, number of electrons in conduction band is equal to number of holes in the valence band. Thus, total current through intrinsic semiconductor is equal to hole current plus electron current. Electrons are free in conduction band, holes are free in valence band. What is hole? Hole is nothing but the vacancy or absence of electron in the bond of a covalently bonded crystal. This vacancy serves as a positive charge carrier and is called hole. And hole is actually not a physical entity. Hole buli asode kuno particle nai. Hole to a deficiency of electron. Clear? That means in intrinsic semiconductors, number of free electrons in conduction band is equal to number of holes in valence band. Okay?